In messy crime scenes, technicians and investigators may be presented with ambiguous stains that appear as blood. There truly is no way to know unless confirming with lab equipment and instrumentation. However, portable confirmatory testing is not quite feasible in the field yet. Instead, presumptive tests are employed to both provide a possible substance indication and increase the confidence level of the technician to what they are collecting. Phenolphthalein, also known as the Kastle-Meyer test, is a presumptive test for blood and is one of the most widely used tests for crime scene response teams. As the name implies, it was developed through the work of two scientists, Joseph Kastle and Erich Meyer. Kastle first discovered the reaction in 1901 using phenolphthalein for biological oxidases, while Meyer, in 1903, applied Kastle's test and found that blood cells triggered the same reaction. Phenolphthalein presumptive tests follow a simple but strict protocol. A presumed blood sample, typically in dried form, is collected with a lightly moistened cotton swab with deionized water. 1 to 2 drops of phenolphthalein reagent are applied directly to the sample before applying 1 to 2 drops of hydrogen peroxide. The phenolphthalein is colorless, and it is only until hydrogen peroxide is introduced where any presumable hemoglobin in the sample will undergo an oxidation-reduction reaction. Essentially, phenolphthalein is the reduced form of phenolphthalein, and the swab should not exhibit any color change when the reagent is applied. When 1 to 2 drops of hydrogen peroxide are introduced to the phenolphthalein applied sample, hemoglobin acts as a catalyst due to its iron group in the heme, which mimics peroxidase activity by decomposing hydrogen peroxide into reactive oxygen before returning to its original iron state. This peroxidase reaction in turn speeds up the phenolphthalein, becoming oxidized by donating and losing its electrons, resulting in phenolphthalein products. It is the phenolphthalein form that generates a bright pink color, indicating a strong presence of heme peroxidase activity. A positive result for this presumptive test would show an immediate and rapid color change to a bright pink, indicating the presence of hemoglobin. However, after about 30 seconds, the swab will naturally oxidize from the air and turn pink. To obtain a more sensitive result, ethanol can be administered before both the phenolphthalein reagent and hydrogen peroxide are introduced. The ethanol works by lysing the phospholipids within the red blood cells membranes, effectively exposing more hemoglobin to be available to help catalyze the oxidation reaction. Additionally, ethanol can also help lower the surface tension of dried and porous stains that assists the reagent to better soak into the stain to expose more hemoglobin. The phenolphthalein test is regarded as a presumptive test only, and not a confirmatory test due to significant limitations. One of these limitations would include specificity issues. The problem is that heme mimics peroxidase activity. Therefore, any biological, chemical, or vegetable materials that undergo peroxidase activity could result in false positives. Examples that give false positive readings include horseradish, rust, and bleach. As mentioned earlier, available oxygen will oxidize the sample naturally after 30 seconds, rendering the test inaccurate and inadmissible if the technician steps away from the test or does not carefully watch the reaction take place. Finally, when conducting any scientific procedure on an unknown, remember to always document the use of positive and negative controls before administering the test. This acts as a quality control measure and improves reliability and integrity by ensuring that the reagents used are working properly. It protects the technician's actions in court, and it helps reduce the potential for contaminants that may create false positives. Always notate the reagent used, its lot number, location of stain and its characteristics, the time the test was conducted, and the procedure followed. Lastly, presumptive tests do not confirm the presence of blood, even when they exhibit a positive result. They must be coupled with a DNA confirmatory test, such as the Hemotrace ABA card or the Takayama microcrystalline test. If you liked the video, consider subscribing to the channel for more forensic-related content.